This is a lesson on trig proofs. So this is an extension of what we have been doing the last two lessons. In this lesson, I'll go through two or three more examples of variations that you'll see when you're solving trig proofs. So prove the following, show all substitutions. So as we've seen, you have to show every step that you do. So if you use one identity, you have to show that you're using it. So here we have 1 plus cos theta times cosecant theta minus cotangent theta is supposed to be equal to sine theta. Now when you take a look at the left side of this expression, you don't have much to work with. The only two ratios that can be simplified would be the cosecant theta and the cotangent theta. And cosecant theta we know is equal to 1 over sine theta. And cotangent theta is equal to cos over sine. Now some of you might be tempted to FOIL these two binomials out first before you make the substitution, and that will work. I'm not going to do that though, but it will work. Instead, I'm going to make the replacements right away. So for cosecant theta, replace this with 1 over sine. And cotangent, I go cos over sine. And then I'm just going to see where this takes me. Keep the right side as is. You could FOIL it at this point as well, but again, I would recommend holding off a little bit. If you take a look at that bracket, we do already have a common denominator, so we don't even have to find an additional one, but we can write it as a single term. So sine theta on the bottom, and then our numerator will be 1 minus cos theta. And all this is multiplied by 1 plus cosine theta. Now if it helped you to see what's going on better, you could write this over 1, because in fact it would be over 1. Now when you FOIL it at this point, you'll notice that we have another difference of squares multiplication. 1 plus cos theta times 1 minus cos theta will take us to 1 minus cos squared theta. So you could take the time to FOIL it out, but you don't need to, because that form is familiar enough. 1 minus cos squared theta over sine theta. And then all you need to do is recall, or take a look at your formula sheet, that since cos squared theta plus sine squared theta is equal to 1, with a little manipulation, we could express sine squared theta in terms of cos squared. So sine squared is 1 minus cos squared theta. Now you can see where this one is going. Replace the 1 minus cos squared with sine squared, which is over sine theta. And if you divide out a factor of sine theta, you will be left with just sine theta, which is equal to sine theta. So we've done it. This would be considered a mid-plus type of proof. Let's have a look at another one. 1 minus tan theta over 1 minus cotangent theta is equal to negative tan theta. Questions like this actually involve more algebra than they do trigonometry. This has way more in common with a rational expression question from, say, Math 10 than it does a trig. There's not many substitutions you can make. All we've got is the tan theta is equal to sine theta over cos theta, and cotangent theta is cos over sine. So without thinking a lot about it, we make those substitutions. And the form might already start looking familiar to you. So 1 minus sine theta over cosine theta all over top 1 minus cos theta over sine theta. So this is looking like a complex fraction, which will require us on the numerator to get a common denominator of cosine theta. So anytime we find ourselves with no other substitutions we can make, such as now, and two or more fractions being added or subtracted, you have no choice. You have to get a common denominator and simplify them like that and then hope for the best. So this means we're going to have to multiply by cos theta over cos theta, and that turns our numerator into cos theta minus sine theta all over cos theta. And then for our denominator, we're in a similar position, except here we have a denominator of a common denominator of sine theta, and that will not affect the second term, so that's cos theta. However, we need to multiply this 1 over 1 by sine over sine to express it as an equivalent fraction. And then that takes us here, sine theta minus cos theta. With the complex fraction, we have to divide, but the division really is going to be multiplying by the reciprocal. So we go cos theta minus sine theta over cosine theta, and this would be multiplied by sine theta all over top of sine theta minus cosine theta. We would like to cancel something, and that cos theta minus sine theta and the sine theta minus cosine theta can cancel, but you have to fall back on something that you've learned in earlier math courses. They're not identical because the signs are reversed. So we just factor out a negative 1 from one of those factors. And if you factored out a negative 1 from cos theta minus sine theta, that cos theta will become negative. The negative sine theta becomes positive. So in effect, what you're doing is reversing the two. So it's a good method to simplify these and then ultimately cancel, because you're going to get negative sine theta minus cosine theta over cos theta, and then this is going to be multiplied by sine theta over sine theta minus cos theta, and now we can cancel those sine theta minus cosine thetas. And that will leave us, I'm just going to take this one up over here instead of bringing up a new screen. That will leave us with negative sine theta over cosine theta. And if you peek over to the right side, we do want it to be equal to tan, negative tan, and that's exactly what we have. Sine over cos is tan, so this becomes negative tan theta is in fact equal to negative tan theta. We did it. This one would be rated as a mid, plus, or higher in terms of difficulty. But we only made a couple substitutions. The rest of it is just a rational expression. Let's try another one. Sine theta over 1 plus cos plus sine theta over 1 minus cos is equal to 2 cosecant theta. This one has no substitutions we can make on the left side. Everything's in terms of sine and cos. Nothing is squared, so there's no Pythagorean identities. So our only hope is to get an LCD. And in this case, we have binomial denominators, but that's not a big deal. It just means that our denominator, our LCD, would be the product of those two binomials. So 1 plus cos theta times 1 minus cos theta, that is our LCD. Don't FOIL it out, at least not yet. You might want to do it later on, but hold off with it for now. And then on the numerator, that sine theta it needs to be multiplied by 1 minus cos theta. And then the second fraction, sine theta must be multiplied by 1 plus cos theta. So it doesn't look like we've helped the situation much. However, once we distribute those signs in, now keep in mind you cannot cancel anything out now. You can only cancel them out if you can take them out of each of a factor out of each of the terms, which we cannot. So don't be tempted to cancel a 1 minus cos or a 1 plus cos. Rather, just multiply the sign in to the first binomial, so that's sine theta minus sine theta times cosine theta, and then that's plus sine theta plus sine theta cos theta, and then over 1 plus cos theta times 1 minus cos theta. Now I know most people really want to FOIL those factors on the denominator out, and I will do it, I promise, but I'll do it on the next step. Now if you look at your numerator, we finally get a cancellation. We have minus sine theta cos theta and plus sine theta cos theta. Those are like terms with opposite signs, so they're actually gone. And then the numerator, sine theta plus sine theta, you're just adding those two like terms together. So that's 2 sine theta. And finally, let's do the multiplication. 1 plus cos times 1 minus cos is 1 minus cos squared theta. You've seen that before. We don't need to spend a lot of time on that denominator now. 1 minus cos squared theta we've seen a few times. If you use the first Pythagorean identity, that's equal to sine squared theta. And all of a sudden, this one looks like it's going to be okay. 2 sine theta over sine squared theta would allow us to divide out a factor of sine theta from top and bottom, which is going to give us 2 over sine theta. And again, I'm going to work this one out off to the side. Just need a step or two more. Now this is kind of interesting because we see the 2 cosecant theta on the right side. You have a choice. You could either convert the sine theta on the left equal to cosecant, because that's normally what we recommend, right? Stick to one side, take it all the way down. The other choice would be to simplify the right side. It would be harmless enough at this point. But I'm going to stick with what I've been doing. I'm going to take that 2 over sine theta, and I'm going to write that as 1 over sine theta. And 1 over sine theta is in fact equal to cosecant. So 2 cosecant theta is equal to 2 cosecant theta. We did it. So this too would be considered a mid-plus type of problem. And that is it. 3 more examples. The next exercise will continue with trig identities, but will involve solutions and trig equations as well. So we finally put everything all together. Thank you for